uh, the internet, the internet base, user base, increasing every other day. It's the application is supposed to handle that type of traffic when you are on the cloud. So, do you design your applications in an architecture that is conducive to that type of environment? So that is a question. And some people, I'm sure most of you have heard of this term somewhere or other during the recent past. But many of you might be wondering as to whether this is a hype or whether this is reality, and so on and so forth. The answer is there are several companies that are doing very solid business using microservices. Netflix, Twitter, Amazon. There are five. I think the most recent statistics show that there are about 600 services running at Netflix. They provide movies, right, to customers across the globe. And the reason why they are so successful is because they're able to expand at such a fast pace. I mean, if you think about it, if you build this whole thing as a monolithic application without using microservices, it will be very difficult for them to scale. It will be very difficult for them to add a new service because the demands of the customers are increasing by the day. And unless you adapt, unless you as a company adapt to that, it's going to be very difficult. So with that backdrop, let me start. There are a lot of definitions that you can find in the internet about microservices, and this is the best, by far the best I found. It's an architectural style. It's an approach to developing a single application as a suite of small services, each running in its own process, which means it will be, each process listening to its own IP and port on the cloud, and communicating with lightweight mechanisms, often an HTTP REST API. These services are built around business capabilities and independently deployable. That's very important. They are independently deployable. They can stand on its own. They take care of one small aspect. I mean, typical example is we build ERP applications in our organization, right, for our customers. Inventory is a typical service, or catalog is a typical service. I mean, these can stand by itself. These have its own database. Of course, in order for the application to function, you need multiple services collaborating with each other. So there is a bare minimum of centralized management of these services, which may be written in different programming languages. That's another key thing. You could have an application built by having one service written in Scala, one written in Java, one written in PHP or Python, and so on. No problem. These all can coexist. Like I said, the examples before, Netflix, Groupon, Twitter, Halo is something, and Uber started as a monolithic, but now it's totally microservice based. So this is just a small example of a little bit more detail on Netflix. I mean, some of the things that I'll talk in more detail. It's like you have got the tooling, the configuration, the discovery, because somebody has to discover these services. Because when a service comes up, the service has to register itself in a registry so that it's discoverable by other services. So these are important, and routing is important because you're going to have to scale. Like you have one instance of a service running, you should tomorrow, if that service cannot handle the load, you would have multiple instances, and you would have to take care of load balancing. You would have to take care of routing to different services because you would have different REST API paths mapping to different services. For example, if you're accessing an inventory functionality, then that's going to be directed to the inventory service. If it's catalog, then you go to catalog. If it's product, you go to products, and so on. So routing is important. And then there is also observability, because you should be always observing if a service is down or up. Because if it's down, then it's like the pattern is actually called circuit breaker pattern. So just like a circuit breaker, if a service is down, you should be able to, you should not basically, pull down the entire application. It's just that one instance of that service is down. Within no time, that will be like, kind of cut off from the rest of the system, and then you would automatically get redirected to another instance of that service. that sort of thing. So each of these different patterns have its own implementations out there as open source, like Hystrix, Zool, Eureka. These are all open source implementations of these patterns, which you can use within your application. Eureka, by the way, is a registry. It's a registry where services can register to be found by other services in the application. And as you can see, it's like Netflix uses Java, Groovy, Scala, Clojure, Python. These are all the different languages they use in their 600 odd services. Twitter is basically Scala, is their main language, and they use Discovery, but then they use Zookeeper. They have routing, they use Finagle, and Zipkin for observability. And Halo is again kind of like Uber, and they use Go. Go, by the way, is a very, very powerful language, and I think that is something that we have to soon, at least in a small group, start experimenting and all that. So this is a traditional application structure where you have you build this is Java-based application. So you have a WAR file that is generated. It uses Spring MVC. You have got, you can see that it has been structured as different services, like you have accounts, transfers, customers, and so on. You have a model view architecture. Everything is fine, but all of them are monolithic in the sense that you run it in one big container, and then you have a RDBMS which has transactional support and all that. Now you will soon find that in microservices there is no transaction support, which means each service has got its own database, which means there is no, I mean, it's a two-phase commit across two services. It's a very difficult attempt. So because of that, they have identified something known as event sourcing. So event-based communication. So we'll come to that later. So this is a traditional architecture. It's simple to develop, test, deploy, and scale. But when you say scaling, how do you scale a traditional monolithic application? It's by having another instance of the server running the whole thing. So it may so happen that the functionality which is being used by most people is one of those services, not all of them. But still, you will have to scale out the entire monolith as a whole in order to satisfy that requirement. So microservices approach, it basically segregates functionality into small autonomous services and scales out by deploying independently and replicating these services across servers, VMs, and containers. So you don't have to replicate the entire monolith with all the services in multiple VMs, just like we do in the monolithic case. But in the case of microservice approach, each individual service can be replicated. And sometimes, as I gave an example before, one service may be replicated 50 times. So you run 50 instances of that, whereas another service you just run 2 because it's hardly used. So when you think of how to scale your application, there are different ways of scaling. So in the x-axis, you see that you have got horizontal duplication, like you have multiple VMs running the same instances. In z-axis, you have got data partitioning. Like database, again, is something that has to scale. So different architectures are available in the sense like you can have sharding, database sharding, like which means you cut your data into some bases based on some criteria like maybe name or something. A to F is in this database, then F to J is in another database, another sharded piece, and so on. So that is one way to shard your database, and then based on your name or something, you just go to the different shard. So that is one option of data partitioning or scaling using data partitioning. And then on the y-axis, you have functional decomposition. Basically, scale by splitting different things, and that is what we are talking about in terms of microservice, where you decompose your functionally you decompose your application into a set of different services. Data sovereignty is one important aspect of microservice, in which each service has to have its own data, ownership of its own data, and that too pretty much independent. You should not rely on another services database or something like that. Now, all the communication, we'll see that it all happens through events. It's a different way of thinking, but then that seems to be very popular, and people are doing a lot of research on that, and it seems to be very fast as well, because events are inherently very fast. So this is the shared database approach in the monolithic case, where you have different services, but then they're tightly coupled. You have the order table, customer table. These are all. I mean, this is an example where you have an order, and you have a credit limit for a customer. So when you create an order, you basically have to go and reduce the credit limit, because or you cannot create an order if your credit limit is exceeded, and so on and so forth. So for that, you have a relation between the two tables, and there is a very tight coupling between the two services. So the other aspect of monolithic development is that you see how the service updates happen. You have each developer in a team contributing to this development, and then you have a QA release, and the QA reports bugs back to the developers, and then they make changes. So every time with a small team and a single language, it might be okay, but if you have multiple languages and multiple teams, you try to build a monolithic application, it's going to be a very challenging affair, because any change requires the whole application to be tested, not like in the case of a microservice, where each one works on that particular service. Each team, which may be a very small team, works on that particular service, and all they do is they just make sure that they write the tests for that service to function well, and then it all comes together. So this is the way in which the microservice works, where you have you have one microservice which is in Node.js, another one on Python, another one on Java or something, Go, whatever, and then each one deploys the feature to production. So you can add new microservices very quickly, and that's the last part, the deployment. You can see the Docker icon there, which says that microservices are very much deployable in a Docker container. So the whole pipeline of design, testing, and finally deployment inside a Docker container, that whole thing is quite fast. If somebody who have experience in building microservices and deploying, they would never want to go back to the old way of having the entire thing running in their development machine, and making sure that you need to have sufficient disk space, you need to have sufficient memory, and it's very slow to build and deployment. So especially I'm talking about large applications. Okay, it may not be applicable for very small applications, but many customers, they are thinking of building large applications and making it available to thousands and thousands of users. That is where this becomes a bottleneck. So some of the design patterns that we use for microservices, API gateway pattern is one important thing, where you have an API gateway, which actually is a reverse proxy sort of thing, where it routes the calls or the requests. These are all REST API requests to different services, based on some configuration. So you have something known as an API gateway pattern. Almost all the cloud providers like Azure, Amazon, all of them have this built in. So if you were to host your service in Amazon, that is one way to use. I mean, you could use their. There are different ways. You can build your own VM, and you can use open source components for this API gateway, and you can have an API gateway instance running in your application as a Docker container. You will hear more about Docker from Kavya later on. That is an important pattern in microservice. Service discovery pattern is another important thing, where you have to discover your service. So there is something known as a registry. Again, this registry is an open source. There is a registry open source implementation called Eureka, that was actually open sourced by Netflix. Netflix, when they became successful, they wanted everybody else to use their microservice architecture, so they open sourced a bunch of components, and API pattern, the service discovery pattern, I mean, they have got implementations of that, and you can use that in your code, especially if you are writing Java based, Spring based and all that. It's as simple as using a simple annotation. Just put an enable Zool, which means you get the routing, and similarly for discovery, enable Eureka, then you get the discovery pattern available in your application, so that when you bring up that service, it automatically goes and registers with the service registry. Again, the service registry can be run as part of your application in a VM, so which means I'm giving you two flavors. Like, you can build the entire application within and run it inside a VM in multiple services. Each service would be inside a Docker container, but then the whole thing can run in a VM. Or you can actually use the publicly available providers like Azure and Amazon and DigitalOcean and all that. They all have some form of the microservice patterns available. In fact, Amazon, I believe, has got something known as Lambda. And this Lambda is nothing but a service. You just write the function and give it to them. I mean, that basically, they'll take care of the entire microservice hosting part. I mean, it's just they say you write a function. I mean, it could be, that function could be doing some calculation or whatever, and they will just take care of all the scalability and everything else. So that is the service discovery pattern. And again, the service discovery pattern handles multiple instances of the same service also. So, and the circuit breaker pattern, as I mentioned earlier, it's again contributed by Netflix. It's called Hystrix. I mean, there are other players that have contributed something similar. So it's like, if a service is not responding within a certain time, it'll automatically, open the circuit breaker so that next time you come in, it goes to a different, service, microservice. That sort of thing. Load balancer pattern, again, it's called Ribbon. That's also contributed by Netflix. So you can actually use Ribbon inside your code so that if you have multiple instances, if you have multiple instances of your application, it can actually load balance. Multiple instances of your service, it can load balance between them. So that is, in this particular case, actually, they have shown 3 different services like product recommendation and review, and then they have got a product composite microservice also that actually invokes these 3 different services. And while invoking these 3 different services, it uses the load balancer, Ribbon load balancer, so that if you have multiple instances of the product or multiple instances of the recommendation, it will kind of intelligently balance the load among these 3. So all this matters when you have thousands and thousands of users accessing the system. Polyglot, again, another acronym here. It's called Polyglot persistence. It's nothing but having different databases for different microservices. I don't know who coined the term, but it's another buzzword, so to speak. It's nothing other than having different databases. So because depending on the nature of your service, you can choose your database. So today what happens is when we design an application, we decide on the database first, right? And we have a lot of reasoning behind why we choose one database over the other. And mostly because it's something that's, the customer wants that database to be used, or maybe because, we are more familiar with it, that sort of thing. But this is like, when you design a microservice, you use it based on the actual need. And I'll show you that, in some cases, it makes sense to use a MongoDB and have all your data expressed as documents for easy lookup. So in this case, you have, you can see that if it's a search engine, then the best database for that is either Apache Solr or Elastic Search. So I mean, today we are not building microservices, but we consciously use Apache Solr in all our applications which use a search. That's a conscious decision because we know that it's fast, it's in memory and all that. So so this is like using that in the microservice viewpoint. So this is like putting all those patterns into one. You can see here that there is the API gateway, there is the registry discovery, there is a circuit breaker, and then there is a river load balancing, and all that thing. Everything is used in one. See, this is where it gets a little bit interesting. You know, single responsibility is something that is very much inherent to microservices, which means each service should do one thing and one thing well, and which means like you have an order service which basically handles orders. So you have an order table and all that, and then you have a customer service. Customer service which handles the customer, and credit limit is one field in the customer table. Now, ideally, normally what you do is in our traditional design, you would basically have a join between the two tables and have one database having the using the storing the data for both the functionalities, right? Now that is not acceptable. That is not acceptable in the microservice field. So that's why that cross is there in the name. So what is the solution? The solution is what is known as event sourcing. So this event sourcing is another pattern in the microservice field, where when you don't really store state in the database. Instead of that, you create events. So when you create an order, you fire an order created event, and the other services should actually and that event actually goes into a table. Like there is something known as an event store, which stores all the events that are created. And what happens is, how do you build the state is by playing back the events from the top. So let's say you have an order created and it is approved and so on and so forth. So all these things, this event store is actually a table, and that table will have the event ID and which event it is, and then some data associated with that event. Maybe the order total and those kind of things. So you have to think in terms of, not in terms of the entities, but in terms of events. And then you think about playing back the event one by one. So once you play back the events, you can build your state, the model state. So this is an example of the event table where you have the event ID, the aggregate, they call it aggregate instead of model, they call it aggregate. So aggregate ID, aggregate type is order, the event ID, event type, and then the event data. Now, if you think about it, if you play back, or if you process each of these events one by one, you will get the state. Now, the only thing you really need to do transactions. So it's like the familiar concept where you have a customer class and you have let's say you have a state called credit limit or something. Now the credit limit has to be updated when you have an order, right? But instead of updating the table straight away, you create an event and you process the event, and when you process the event, that's when the state gets updated. So it's doing the same thing, but then it's doing it in a different way. That's all. And this is the final example where the order also has a state, which means if the credit limit is above the limit, then you have to fail the order, right? And if the credit limit is below, then the order is in an accepted state. So again, the order the order state, in order to change it as accepted, again you have to pass on, you have to use the events. There is another interesting thing here called command query responsibility separation. So every microservice has to treat commands and queries separately. Commands in the sense they're all posts. You do a post, you do a delete. I'm talking about HTTP REST calls. They are all commands. and then there are the gets are actually the queries. So you have a different way of treating the posts versus the gets. You can see here the posts actually are creating the events in the event store. That's the responsibility of the command part. And the responsibility of the query part is to listen to events. And these events can come from any service. It doesn't have to be from the same service. It could be from another service. So when the events are processed and you build the materialized view, and that is what you return in gets. So if you have a get coming into your microservice, you actually return from your materialized view, which could be a database. It could be a database that where you build the final data that are returned in queries. So this is actually an example of the way the events are, the commands are processed by creating new events. You can see here that if available credit is greater than or equal, then you create a new customer credit reserved event, that sort of thing. And this is on the customer side. And on the order side also there will be similar commands infrastructure where events are created. And this is how you apply the events. You can see here that the state is updated by applying the events. This is another example of how a restaurant builds a materialized view of restaurant's opening hours for a query. So it listens to events from the event store and it builds the database appropriately for query. So this is one example of how you could build an order history in MongoDB, where you could have a document that actually can store the list of orders for a customer. Now today what do? You do an SQL query, right? You do a SQL query of all the orders and using the customer ID. I mean, that is what you normally do to retrieve the list of orders. Now think about this. You could actually have a service build this for you. I mean, they build the customer service could actually keep a list of orders, and it can be very quickly search-wise and lookup-wise. It can be very fast when you store everything in as part of the same document. So that is the perspective that you should design microservices with. And as far as the deployment pipeline goes, you build and test microservice independently, and then you can actually put it in a Docker image, and you can build and test the Docker image, and then finally you can deploy the Docker image to the registry. So you can have Docker Hub used as a registry for your microservice, and then it's out there, it's functional, it's tested, everything, and you can actually using Docker commands, you can actually pull and compose the whole application from the registry. So that is the way you do the deployment pipeline. I also have to mention that the reactive manifesto, which means reactive programming. I don't know how many of you are familiar with reactive programming or heard of it. That's a new way of writing programs where you don't really write synchronous or blocking type of programs. I mean, you make a call into an API, you just block the thread, right? And then that API does the job and comes back with the result, and then you return. Now, instead of that, the reactive programming is using events again, and that is why I wanted to put this slide here, because microservices is very much goes in an event oriented manner. So that's why there is a strong relationship. So if you're writing microservices, please make use of the event or please make use of the reactive programming in your application, because reactive programming is now available in almost all the languages. JavaScript, Java, C#, PHP, every language has got reactive type of support in it. It's only that we have not used it, because we are familiar with writing in the old-fashioned way, which is like because this has evolved over time, and people realize that time is of essence now. I mean, you cannot really wherever you can shave off a few microseconds or milliseconds, it's going to contribute to the entire application being faster and faster. Because that's what the entire world is looking at. Because unless an application is very responsive, I know we are facing that issue with Impulse. In that perspective, wherever you can shave off time, you should do that. And right now, all languages support reactive methodologies inside. It's just that you may have to use a different API. It's also, it goes hand in hand with functional programming, where you write functions and you pass functions into other functions so that it calls you back. So you don't really hold the thread waiting for that to come out. You just pass on a function and say, I am done. You call me back whenever you have the data. So that thread is free. You see the advantage there. Instead of me holding the thread and making a function call and waiting for the data to come back, I am just passing a function to you, to the called function, which may be another function. You call another function, pass on another function, say you call me back when you're done. So that sort of programming is something is called reactive programming. It's pretty fast. So it's responsive, it's resilient, it's elastic, and it's message driven. Mostly uses events. So that's why the separation between microservice and reactive programming. Some of the microservice frameworks that are available today. In Java, you have Spring Boot and plus Netflix OSs, because Netflix OSs has been open source. So Spring people, they just grabbed that and they built it into the Spring Boot. And then Hipster is another upcoming framework in Java. You can actually, it's very easy. You just download and install Hipster and just follow the instructions. It will just ask you questions. Do you want to build microservice? Do you want to build monolith? If you want to say microservice, then you say yes, and then you go to the next. Which database do you want to? It's all like a question answer kind of thing. And finally, you have the base application ready, and then you can play with it. You can add on to the microservice. And in Node.js, you have Seneca and Aqua.js. In Python, you have ZeroMQ. .NET, you have Service Stack. And the first four are based on languages. The last two are based on the cloud providers. AWS has got Lambda, and Azure has got Azure Service Fabric. Of course, the difference is that if you use AWS or Azure, you have to use their shell or base frameworks like the discovery and API and routing and load balancer and all that. So you got to use that. So probably they will charge you for that. So, but it's good that you are aware that it's available, so that if there is a customer out there who wants to host this in AWS, you have this option of using Lambda, or you can build one of your own using any of the other requirements. And Spring Initializer is another site that you can go to, and you can actually it's very simple. You can generate a full-fledged microservice application, and you can add on what all you want. You want the database access, which database, security, what type of security. If it's a web application, then you add the web and all that. And finally, it spits out a complete Spring Boot based microservice. Hipster is also another framework. Again, all the different things that I talked about, like the registry, the Eureka, the load balancer, everything is there. Again, it's based on a question answer type of thing where you can build an application from scratch. So this is something that you could try out if you are a Java enthusiast. So that is my presentation. It's basically I just wanted to introduce you to the world of microservices, and I think in future we are going to get asked by our customers about scalability a lot. Yesterday we had this client from MEP Links. We were discussing about various things, and they have got about 6 or 7 services packed into a monolith application. And that's what we built. It's not microservice, but we can definitely host that, and I think over time, if the site becomes popular and if we have a lot more requests coming in, I'm sure we'll have to take out one by one the services and then host it as microservice. That's what I think, and that's the journey that many applications have taken. Most of these applications like Twitter and they all have been monolith when they started. Nobody starts out with microservice approach straight away until now we have all the tools that are available. But now all the existing applications start out like that. So keep that in mind, and probably we'll soon have a chance to build a microservice-based, an application based on a microservice architecture. Thank you.